What do we mean by how to use asset tracking to maintain complete chain of custody? The main objective of this webinar is to discuss the importance of location to achieving complete chain of custody. The chain of custody follows materials and assets through every step of the supply chain as they go through sourcing, production, manufacturing, multiple shipping routes, all the way down to retail, home delivery, or wherever those goods end up. It's done through a series of procedures, documents, and a varied stages of technologies. The ability to provide supply chain traceability along the whole supply chain provides us insight into the product's origins, components, and the variable parties that take part in the process. Let's dive in. Thinking about assets, every one of us, when he thinks about assets, has a different picture of what an asset is. An asset, it could be your new phone, your new television, a car, your shoes, anything you wear, a pizza. Anything that is made is an asset. Anything that is made goes through the supply chain. That includes, by the way, also the tools to manufacture the assets themselves. So everything, anything physical, moving from place to place is an asset and is part of the supply chain. Now, of course, when we think about it, it's very easy. It's made somewhere. And then there's the simple picture where it moves, goes to the store, goes to our house. It's ours. So very simple. No, it's not that simple. I think that is what the supply chain story is about. The supply chain story is about the journey. And in the journey is varied. The journey, we've made 1, 2, 3, 4, 5, 6, 10 parts to the journey here, and we've really dramatically simplified the journey. The journey is unique to every company, is unique to every product, is unique to every process of moving along goods from country to country, from manufacturing to logistics to retail, using multiple modes of transportation, be it air freight, ports, trains, trucking, delivery trucks, delivery mopeds, everything. Everything is part of the journey. And in the same way, we always, when we encounter customers, we learn that we don't understand why they need our solution. We have to understand their business to understand why they need our solution. In the same way, everybody's supply chain is different. Everybody's journey is different. Just two small stories from our last 6 months of working with customers. A CPG company, Central US, we're in their main distribution center, or we thought is their main distribution center for the area. And we learned that that statewide distribution center has county-wide distribution center, above it a regional distribution center, and beyond that, what they call the sector distribution center. So everything in their life revolved about moving between 4 or 5 layers of distribution centers that you come to the store and you expect to see your toothpaste there. You don't understand that it went through 8 distribution centers. Another parallel process, we're now doing a large pilot with a plastics manufacturer. And as they're still in the manufacturing process, they are moving the manufacturing itself between 3 different manufacturing sites for every stage of the manufacturing. So their journey, right, stuck at the left side here, within the first part of the journey, is still has 3 parts before it goes anywhere. So everybody's journey is different. A lot can happen during the journey, and that is really the essence and the problem and the need for a chain of custody. Physical security risks, inaccurate or insufficient data, lack of standardization, poor integration and communication, all these things, human error, and of course human malfeasance, all these things can happen because we're moving from place to place. We're shifting countries, we're shifting geographies, We're moving responsibility between different factors, and the cost of the things that can happen during this journey, and let's call the things that can happen during this journey by a general name: supply chain disruption. So supply chain disruption can have a dramatic financial impact. It can impact lack of resources in the production line, lack of warehousing, lack of container space, shortages everywhere, lack of products in the store. Everything can result from supply chain disruption. It could be direct revenue loss. And let's not disregard this. A single stoppage of 30 days on a single manufacturing line can cost a Fortune 2000 company 3 to 5% of their EBITDA. That's a single 30-day disruption can cost 3 to 5% of your EBITDA. In a survey last year, 2022, so post-pandemic crisis of supply chain disruption, 2/3 of Fortune 2000 reported losses between 3 to 15% as a result of supply chain disruption. So that's direct revenue. Productivity is impacted. Attempts to reach your maximum productivity are curtailed by not getting the right components in time, etc. Price can increase. Any supply chain, whether it's shortages of warehousing space, shortages of port space, or maybe overabundance of them, which will lower prices dramatically and create a shortage later. So the whole supply chain really is always dramatically open to disruption. Just a few numbers. Lost and counterfeited cargo as a result of supply chain disruptions in pharma last year, $60 billion. In automotive, $45 million. In pharma, as a result of breakage of the cold chain, $35 billion lost last year. We are talking here very big numbers. An IBM survey of, again, Fortune 2000 noted that if there was full visibility of the supply chain, productivity could rise by 28%. So this is the challenge we're looking at. What's the solution? Solution is chain of custody. Okay, nice description here: certification mechanism enables goods, etc., 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 etc. You can all read what chain of custody means. In essence, what it means is a chronology of ownership, custody, and location. Three things: ownership, custody, and location of anything moving between parties in the supply chain. The term chain of custody, you all know that from television, from your favorite crime drama, is really the chronological documentation of a paper trail. Okay, you're recording sequences of custody, control, transfer, analysis, materials, physical. That's the legal sense. There, how did it move into the commercial sense? It started with sustainability, really. Chain of custody is used to validate claims made about product, process, business, service covered by any type of sustainability standard. And there's a lot of definitions of sets and requirements and measures that provide the necessary controls for movements of materials and products and any type of a sustainability data. So really, legal, then sustainability, and there's quite a lot of, if you're ever interested, literature on different models of sustainability, chain of custody, etc. And it is a crucial part there. But what interests us now specifically is the next stage, really. It's the general chain of custody, okay? From the legal sphere to sustainability to the general supply chain. It's basically getting a grips, remember, of ownership, custody, and location in this whole process of the journey of your goods from place to place. Now, what do we gain with the complete chain of custody? It's clear that, unfortunately, still 75% of supply chains basically survey their chain of custody in a non-automated way. So 75% are still manual in the way they cover their operations. But every study, nice quote from Forbes from last year, organization best able to manage the supply chains were the ones that embraced digital transformation. So digital transformation allows us to collect more information in a faster manner and avoid those pitfalls of the journey. So any organizations that went into a digital transformation curbed some of the costs related to supply chain disruption, had greater visibility, so they could act in a timely manner to respond to demand, to secure supply, and keep customers informed. And in the end, when you are able to mellow the changes in the supply chain, you get your people, your most expensive resources, to focus on what they need to do, which is create your product and supply your product. So what do we gain with chain of custody? We gain visibility of assets, process efficiency, lower TCO, safety compliance, elimination of theft, loss of goods. Everything here is doable and achievable if we have that chronology, complete chronology of ownership, custody, and location. Last but not least is regulatory compliance. And the reason I wanted to emphasize the regulatory compliance and the regulatory issues here is because the regulatory issues deal with two industries that are leading the way in terms of chain of custody in the supply chain. And I believe that this is where we're going with everything. So we're starting with pharma. Pharma was the first. It's quite understandable why it's the first, although not the point of this discussion. But in the US, it's the DSCSA, the Drug Supply Chain Security Act. By the way, to those unfamiliar with it, it's already a 10-year process. And November 27th, 2023 marks the 10-year deadline set by the statute, which means that on November 27, 2023, every pharmacy in the US is required to accept only drugs that their full movement through the supply chain can be traced for sale. By the way, the European Union has a similar directive called the Falsified Medicine Directive, EUFMD, with literally same parallels. Now, why is the pharma important? Why do we learn from the pharma so much? Because the size of the industry is so large. The global pharma industry will have over $1.9 trillion of sales revenues by 2027. And it's mixed between online healthcare, between pharmacies, between multiple modes of distribution. So the journey is varied. Just the track and trace market for pharma is expected to be $2.9 billion by 2027. And now this is what I want to learn from this. Everyone studying the pharma chain of custody notes one thing. If you increase granularity of traceability, you have better chain of custody and better control of your supply chain. So the term I want you to remember, granular traceability. After pharma, it's food. The FSMA 204 goes into effect on January 20th, 2026. Some of its rules are already applied, and it basically regulates all food facilities in the US except some meats and certain egg products that are regulated by the Department of Agriculture. So all US and foreign companies that manufacture, pack, process, or hold food sold to US consumers need to comply with FSMA 204. And what does it establish? Surprise. It establishes a food traceability list. It defines the record keeping needed. as food moves through the supply chain, companies are required to collect data points at critical tracking events. What's a critical tracking event? Any type of change, harvesting, cooling, initial packaging, secondary packaging, first land-based receiving, any transformation. The more critical tracking events happen, the more granular traceability, the better our ability to guarantee that the food supplied to the homes of Americans is safe. Same is true for us guaranteeing that when you sent avocados from a certain place and they were delivered to a supermarket 7,000 miles away, it's the same avocados that made it there. It's the traceability and the granularity of traceability. And the granularity of traceability is dependent on one thing: location. You cannot have granular traceability without location. So location is a nice word, but what do you really need for granular traceability? Location is not enough. To those that are not, which I presume is all of you, not native Hebrew speakers, I'll start with the word precision, because our company, Deeyook means precision. And in that, this is our starting point. We're able to provide a location solution that's precise. But that's only the starting point. Precision is the starting point. It has to be precise, because if what you're locating is not precise, you cannot provide the traceability, the granular traceability that's needed. Okay, just think about it. You have, let's say, a pallet, and you need to track it, and a pallet is 2 feet wide. If your precision level is 15 yards, you can't track that pallet. Take the same thing for a box. It's a foot. You need to trace it by a foot. So everything here needs to be in inches, in feet. But precision is not enough. You have ubiquity and you have scalability. So if we say granular traceability, it means traceability in multiple places and everywhere. You can't track things only outside. Now think about what you know about the GPS industry. $570 billion will be the size of the GPS industry within 2 years. And it covers 10% of human activity. Okay, 10% of human activity happens outdoors. 90% of human activity happens indoor. And think about the supply chain. Any manufacturing plant is indoor. Any distribution center is indoor. Multiple types of distribution center is indoor. Retail is indoor. Your home is indoor. 90% of human activity is indoor. To have a granular traceability, you need to provide location that's ubiquitous, indoor and outdoor. To do that, in the end, it needs to be scalable. Why does it need to be scalable? Because the size and immensity of the challenge is such that basically you need to provide global coverage everywhere. Can you deploy infrastructure everywhere? Not really. It needs to be something like that GPS in the outdoor, that GPS that exists there because the US government initially put satellites in the sky and let everybody use them. But it has to have an infrastructure that's scalable. So let's look at the existing solutions. GPS and GPS RTK, which is the current generation of GPS, which provides much better precision. Still, ubiquitous they're not. They're available only outside, and I'll remind you, 10% of human activity. Precision and GPS RTK can be very good, but only where GPS reception, meaning the ability to see 4 satellites at the same time, exists. Scalability, I would say not bad at all. The infrastructure is there. How about legacy indoor solutions? Wi-Fi, RSSI in time of flight, BLE, UWB. The big issue is scalability. you need to deploy infrastructure. Infrastructure is expensive. In many cases, it could be prohibitive. If you need to cover the supply chain, the price is beyond anything that can be done definitely by private economic entities, and I do not think that it's a government project that anybody will take by themselves. Numbers we know and are familiar with, $1 per square foot. So UWB, let's say, $1 million to deploy 1 million square foot. Crazy numbers. And 1 million square foot, what's 1 million square foot? There's so many millions of square foot just in warehouses out there that the cost is truly prohibitive. Precision, in some cases, good enough, but precision for what? Can every pallet, every box be accessed and precisely located? Question. The fact that you can locate a single item doesn't mean you can locate 50,000 items in the same place. So there's an issue with precision. Can you provide precision to the masses? And ubiquity, we've already discussed that. So what is Deeyook offering? Deeyook is offering a solution that's based on the 8.5 billion access points out there. Scalability solved, right? There is Wi-Fi everywhere. Every year, 500 million to 1 billion additional access points are added. 500 million to an additional billion wherever humans are active are added. That 8.5 billion access points is what we at Deeyook use to provide that combination of scalability and ubiquity and precision. We already noted that's our name, and of course, I'll tell you why we are precise in a second. So what Deeyook does is really a technology breakthrough. It's mixing two things, interferometry and building an AI-based physical model. Interferometry is based on wireless propagation, and wireless propagation in space is very useful for tracking. All of us are familiar with radar. Radar is a great example of wireless propagation. However, radar is by definition a two-way propagation paradigm, A to B to A. It measures propagation time at the speed of light. Since the speed of light is enormous, flight timing errors are catastrophic. Interferometry measures angles, not distances. Interferometry is not a direct function of the speed of light, but rather wavelength. In typical wireless applications such as Wi-Fi, the wavelength is 5 to 12 centimeters, a very reasonable size to design an access point. Furthermore, interferometry is by nature passive. So the access point transmits, a client receives. The client, this feature has huge advantages. No need to change the access point. Signal is received from the infrastructure. Client can use any access point. Remember, 8.5 billion. No consent is needed from the access point to measure interferometry. The access point is never aware of the client. Devices never interfere with each other. Any number, you pack a warehouse with 200,000 pallets, any of them can get location, they never interfere with each other. Interferometry is based on measuring the phase difference between two coherent wavefronts. Okay, so we just did interferometry. Now let's go to the physical model. The physical model, when using coherent wireless transmitters, such as access point that we just mentioned, measuring the phase difference between the antenna elements in them is done in a patented method, which is specific to any OFDM modulation. Now, what's OFDM? OFDM is really a modulation used in any high data rate wireless protocol. Deeyook's first product is a Wi-Fi product applicable to 802.11n, AC, AX, etc. But our patents, 8 US granted patents, are not Wi-Fi patents, they're OFDM patents. So they're applicable as well to LTE, to 5G, to what will be 6G. And probably in the future, we will add 5G capabilities or other cellular capabilities into this system. The constellation of all these interference patterns can be modeled. And that's what we mean by AI-based physical modeling. So we're modeling the constellation of antennas in any specific physical area. The model will dictate expected phase difference readings at arbitrary locations without ever reading signals there beforehand. So no prior measurement. A model creates the interferometry for arbitrary locations. The model is then reversed, and using data science, we're able to predict the location given the readings. Let's dive just a little deeper inside, okay? So on the right-hand side, an access point. On the left-hand side, a sensor, basically an OFDM, or in this case, a Wi-Fi tag that we connect to a box, to a pallet, to any type of asset. So we, as I noted, we leverage wireless OFDM, standard modulation. The access point has to have 2 or more antennas to substantially, and those 2 or more antennas are always there to improve the service to connected mobile. Together with smart digital signal processing, the DSP in the access point, this coherent transmission makes the access point smarter. It eliminates the black spot leading to poor reception around the access point. Just as a side note, the coherent transmission in every OFDM standard is a result of a 2000 Ericsson patent that's accepted into every standard that basically solved for us old timers the problem of disconnections. If you remember cellular phones back in the late 90s or early 2000, you could walk around and suddenly get disconnected. That doesn't happen anymore because of this coherent transmission, Ericsson patent 2000. Our innovation exploits this DSP and antenna configuration, the AP, to extract an angular direction from the AP to the individual client, mobile, etc. The client is merely receiving the beacon packets, and you can see a beacon packet going out that the AP sends repeatedly. So the AP sends beacons at constant intervals of 1/10 of a second. The receiving omnidirectional antenna in the client is orientation insensitive. So all 802.11n ACAX protocols, and it supports 5 gigahertz, 6 gigahertz, and 2.4 gigahertz. Our IP, our patents, teach us how to passively extract the direction of departure from this standard base MIMO signals that were designed to be direction insensitive. Our direction estimation is dead reckoning free, so it does not degrade over time. The mobile is extracting the interferometric data out of the ordinary Wi-Fi chipset already populated by any Wi-Fi radio. So what does the flow look like? Given the direction at which many APs view the mobile, the client, the geometrical problem is solved, providing a real-time location. So you really need that access point 1, access point 2, access point 3. In order to save power on the client side, because remember, the client is sitting on a pallet, on a box, it's in the supply chain, we're basically moving through a backhaul, Wi-Fi or cellular, moving it to the cloud, doing all the location calculation in the cloud, in the database, and through a software API, we're providing to any location-based app as a third-party WMS, warehouse management system, geofencing system, chain of custody control system, navigation tools, etc. So process: 1, interferometry; 2, stream to the cloud; 3, determine an angle; 4, angular space; 5, geographic position. Key features then: location as a service, unattended automated service bootstrap, self-improving by implicit crowdsourcing. It utilizes I can't stress this enough. A ubiquitous infrastructure of 8.5 billion APs and base stations. It can give you accuracy of 4 inches. It's only firmware on the client side. Power consumption is a fraction of that of GPS. It's effective, it's robust, indoors and outdoors, it's weatherproof, and it has a super fast cloud connection because it's a thin pipe backhaul. And by the way, it can be operated in an on-prem solution as well. Last but not least, unlike everything done by Apple, Google, everybody and his sister, it's non-invasive location data extraction. But what does all this give us, really? It gives us granular traceability. What type of granular traceability? Continuous traceability. Okay? Deeyook enables continuous traceability, and continuous traceability is the key because it's the most granular of traceability. There is no breakage point the minute you have continuous traceability. Basically, you have an issue where your traceability events are continuous. You track everywhere, indoor and outdoor. You rely on existing infrastructure. 8.5 billion access points out there. You locate with sub-meter precision. Continuous traceability is the most granular traceability possible. Thank you very much.